welcome back. I'm so glad you've come back and we're watching part 2 of the lesson, but part 3 in the lesson, okay? So we're going to talk about the ref and ruff, okay? So REF versus RREF, okay? What's the difference? Okay, we're going to discuss all that. So just be patient. All right, first we're going to talk about, make sure you write this as row echelon and reduced row echelon, okay? So let me just give you some rules. You don't need to write it down unless you want to. It is pretty verbose, okay? I'm just going to warn you. All right, let's go row echelon first. Row. So REF. If I tell you to write something in REF or to simplify something to REF, there's a certain criteria that has to be satisfied, okay? So for example, A, all rows consisting entirely of zeros must be at the bottom. What does that mean, okay? All rows consisting of entirely zero, all has to be at the bottom, okay? So just keep that in mind. I'll give you some examples of it. Part B, the first non-zero entry of any row must be a 1, and that's called the leading one. The first non-zero entry of any row, imagine that, must be a 1, okay? The leading one in a higher row must be to the left of the rows, okay? You guys, you should be writing this down actually, just to keep yourself. Later, you're just going to be able to recognize it, but for now, just so you can have these rules, okay? The leading one in a higher row must be to the left of the rows beneath it, okay? Now, how about, that's it for row echelon, so ref, okay? Now, reduced row echelon is all this and extra. One more step, D. Every column with a leading one must have a 0 in every position above or below it. Okay? So let's read that again. Every column with a leading one must have a 0 in every position above or below it. So basically, I will show you some cases, okay? So you know what we're going to do? We're going to give you some examples, and you're going to tell me whether it's a ref or nothing, okay? So let's go ahead and do this. Why don't you guys take a few minutes, okay? Determine whether each matrix is in a row echelon form. If so, determine whether it's in a reduced row echelon form. So REF, okay? Maybe we can do REF or RREF, okay? So before we go through the answers, why don't you guys take a few minutes right now, take a look at the definition I gave you just a minute ago, and see if you can identify which ones are REF or RREF or not at all, okay? So take a few minutes to do that. Stop the video, write these down. Okay, so you guys, welcome back, okay? Now, let's identify the easiest ones first. Now, don't forget about the leading ones, okay? The leading ones. For example, here, that's a leading one, that's a leading one, that's a leading one, that's a leading one, right? These are all leading ones here. Let's do the easiest one first, right here. Is this one REF or RREF? This one, you're right. It is, because you see how the row of all zeros is not at the bottom, so that's not good, okay? The last row has to be all zeros in order for this to be in either RREF or REF. So this guy is going to be none, okay? So it's no. This one is absolutely no, okay? Can you find another one that's no? I'm sure you found one already. This one is also no. In order for this to be REF, what does it have to be? Maybe this row had to come this way, and this row had to become this way, right? In order for us to be in any kind of form, okay? How about this guy here? Why is it no? Why is it no? Okay, so we have everything below the 1 is 0. But how about this guy here? Because this leading one is okay, right? But what's wrong with this guy? What does this guy have to be? This guy needed to be a 1. Okay, if that guy was a 1, it could have been REF, okay? Let's go here. Is this one REF? Let's check, okay? Are all your zeros below the leading one? These are the leading ones, okay? Everything below is a 0, right? And this one doesn't have any more, so that's okay. And that's why this one is REF. Above and below, not 0. Requires backwards. Okay, so you'll see why this one is REF better too if you don't see it right away, okay? But basically, everything below has to be 0, and you have to have leading ones. Anything above is okay, okay? Let's go here. Is this one REF? Let's look, okay? The first leading one, that's another leading one, that's a leading one, that's a leading one. And below it, right, is all zeros, below it. So second row, below, third row, below, okay? That's all REF. It's an easy way to say. I'm sure you guys got these right, okay? Let's go here, okay? So this one is all zeros, but you remember this has 3 rows and 4 columns. So you're gonna have some sort of like, it's not gonna be nice as like a 4x4 matrix per se, or a 3x3 matrix, which are called square matrices. We're gonna talk about that later, okay? Square matrices. So here, all zeros, okay. How about below here? It's all zeros. It's the leading one, all zeros. And here the leading one, it's zeros and zeros, okay? So is this REF or is this REF? Okay? So this one is REF, but actually more than that, it's REF, okay? Right now, we're just kind of going over it with the definitions in mind, but you'll be able to recognize it, trust me, okay? How about this one then? Is this one REF or REF? Let's look. Below, zeros, leading one. Leading one, leading one. Above and below, zeros. Above and below, zeros. So this one is REF, but more importantly, it's also REF, okay? So right now, that was a really quick introduction to REF versus REF, but you'll know. So let's move on, okay? Don't worry, you'll see so many examples. All right, now let's go to part 4. We're almost done. Part 4 is elementary row operations and Gaussian elimination. You're really, really doing this now, okay? So we're gonna do REF with back substitution, write that. Now, whenever you have a form in REF, it's gonna require back substitution. But just keep this in mind also. If you have REF, then you won't need back substitution. It's gonna be solved for you. And that's what I'm trying to tell you. Once we start rolling with this, you'll understand better, okay? So what I'm gonna do is I'm gonna give you some rules for elementary row operations. Write this down, part 4, elementary row operations, okay? I'm gonna give you some rules. Because we're gonna actually do an example. Number 1, elementary row operations. A, interchange 2 rows. So I'm giving you some rules, things that you can do. So what you can do with elementary row operations, you can interchange rows. So if your first row and second row, you can switch them around. As long as all the first row and entire second row, you can switch them, okay? You'll see when we need to too. B, multiply a row by a constant. As long as you apply the constant to the entire row. For example, if I had 1, 2, 3, 4, 5, 6, if you want to multiply the whole row by a number, like a 5, you can do that as long as you do it to each term, okay? Don't discriminate. C, add a multiple of a row to another row and replace. This is a tricky thing, so I'll demonstrate that for you. Add a multiple of a row to another row and replace. For example, if I multiply this by a 5 to each of these terms, I could add it together, they're saying. What does that mean? Okay, so that's what we're going to discuss right now. All right, so here's what we're going to do. Are you ready? We're going to attack a problem. We're going to do number 27 from your book. All right, number 27. Let's write this down, okay? And it's going to I'm going to go through it step by step for you. Solve using Gaussian elimination, REF. Gaussian elimination is REF. Gaussian elimination is REF. Row echelon form and backward substitution. We're going to solve this sucker, okay? So clearly we're solving for an XYZ because this kind of stemmed from a linear system, right? And we've converted it to a matrix form, okay? All right, so I'm going to take this step by step. Now, our goal is to get into REF, right? That means we want leading ones. So whatever this value is, we want 1 here and 0 here. And we want 1 here, and anything could go above it, okay? Our goal is that, okay? That's our goal. We want leading ones. And look at this. This guy's already a leading 1. That's great. So leave it there. We don't want to change any of them, okay? Not yet, okay? All right. I'm going to take you through this step by step. It's a little tricky, so I'll help you when I get back as well. Add -2 times row 1 to row 2. Are you following along? Okay? Add -2 times row 1 to row 2. What the factor does that mean, okay? So here's what we're going to do, okay? I'm always going to write the actual problem. It says add -2 times row 1 and add it to -2 times row 1 to row 2. So here's what this means, okay? Later, when you get better at this, you don't need to show me this kind of work, okay? But this is what it's saying. -2 times row 1 added to row 2. Okay, that's what that's saying.